Hi, back in the old days, if you were a wizard, you had a lot of spells to learn, and that aspect of it certainly hasn't changed. And the particular form of wizardry that we're going to look at today is electronics. This particular video is the very basic level, so we're going to show you a few basic things about electronics that'll help you decide whether this is the kind of thing, the kind of magic that you're interested in. Electronics probably began about 120 years ago. And if we turn the clocks back now and we go back in time to around 1940, we can see that electronics had reached a fairly developed stage by then. Radio was in its heyday. Clocks were still firmly mechanical. Electronics hadn't entered that domain as yet. But let's take a look inside one of these radios. So I'm going to look at the largest radio here. Just turn it round, and I'm afraid it's somewhat dustier than I would have liked, but there we go. And what do we see inside here? Well, the majority of it's taken up by this big metal chassis on which everything is mounted. We can see radio valves here. These, of course, are an obsolete component that we don't see any of in today's electronics, or at least not often, perhaps in a few amplifiers and things. But there's a transformer here, and we see a lot of those in modern electronics, and we'll talk a little bit more about what that is in a moment. But if we turn the radio up so it's lying on its face, we can see underneath what's inside that metal chassis. And there's a whole bunch of components, all higgledy-piggledy in a terrible mess here, soldered onto little strips of insulating material. And that's how the circuits were built at that particular time. But we still see, if we look here, a lot of components that are not obsolete today, although they manufactured them in a slightly different way. But what we see here is we see resistors, we see capacitors, and some other components I'll talk about. There's only really a handful of components. It's like by the time you've probably got 5 or 6 components and you know how they work and what they do, it's like you've got a good idea about most of electronics. So here's a board out of a laser printer. So this is a modern circuit board. That rat's nest of wires that you saw previously in the radio has been replaced by this very tidy, what's called a printed circuit board. And if we just look, here's a printed circuit board that hasn't had any components put on it. And of course, this is essentially, there are electrical conductors that run through this printed circuit board that connect up the various components that you see on it. And as before, we can see some transformers, we can see capacitors, and we can see resistors. So there's a lot of the same components appearing on this board, which was probably manufactured sometime in maybe 2005, 2006. And we're seeing components that we've also seen in a radio that was manufactured in 1940. There are a few changes. Of course, we don't see any radio valves here, but we see transistors. There's a few here. And we also see integrated circuits, which are actually a circuit board very, very small in silicon, which also will have capacitors and resistors in it too. So those 5 or 6 components that I was talking about that seem to be, vital to electronics, those really are the basic magic spells for the magic of electronics. So let's have a look at some of those components in the raw, so to speak. Well, this is my little box of capacitors and resistors, and I've got these little cards here which help me to read the values on them. As you can see, there's a color coding scheme here for the resistors, and the capacitors have another coding scheme which doesn't use color. But so here's some resistors, different values of them all put in little boxes, and we can potentially, let me see if I can find some that have a nice, you can see the coloured bands on these. If I put something behind them that's white, perhaps, they're easier to see. Yeah. So little cylinders basically with coloured bands on that tell me what the value is. Not all resistors look exactly the same. Sometimes you'll get them and they'll have a little blue background or a green background, as in these ones, but the coloured banding scheme is still the same for those. The capacitors are a little bit clearer. These ones have got the value written on them. And here's some more other capacitors. Again, little tiny discs, these ones, and some other capacitors here. So, but they've all got values written on them and coded on them in a fairly standard way, so we can keep everything in order here. I've also got a few transistors in here as well, and we'll talk about those later. These are really what made the radio valves obsolete, little 3-leaded devices. You can see that if I just put my finger, or I put it in the background here, so there they are. Different types of transistor out there, but essentially that's one of the main parts that gets used in a modern system, modern electronics. And these are diodes. These are 2-leaded things that just about see one there with my finger behind it. So these are really the things we're going to be learning about, and as I say, there's probably 4 or 5 that are essential to pretty much all of the electronics that we're going to do, and we're going to play with those a bit later on. And but before we do that, I need to introduce you to some basic ideas about electricity. Everyone's probably familiar with these batteries. These are AA's. They're 1.5 volts. 1.5 volts tells you how powerful they are in terms of how much pressure of electricity they create. So if we put 2 of them one after the other, we actually get 1.5 volts times 2, which is 3 volts. And if we put another one, then we'll get 4.5 volts. And so on and so forth. And luckily, to save me holding all these batteries one after the other, I happen to have some little battery holders, and this battery holder will allow me to put 2 batteries together to give me 3 volts. And if I connect these 2 wires onto either side of this little bulb, the bulb will light up. So what's happening here is these little batteries that are like water pumps almost, but electricity pumps, and they're pumping with a force of 3 volts and pumping the electricity around through the bulb, and then it goes back to the batteries and then around again, so to speak. What would happen if we put 4 batteries? So we got twice as many pumps, so we got 4 1.5 volts batteries here, so that's going to be 3 6 volts. And if we pump that through the bulb, then what's going to be the difference? Well, surprise, surprise, it's a lot brighter, because of course there's a lot more force there pumping that electricity around through the bulbs. I've got 2 bulbs here connected one after the other, so therefore those bulbs are going to give twice as much resistance to the electricity flow as this bulb here. So what I'm expecting to see is that when I'm just connecting to one bulb, it was very bright, but when I'm connecting to the 2 bulbs, it goes back dull again. So let's just connect with one bulb again, and you'll see that's very bright. In fact, I could connect to one of these bulbs. That's very bright. Or connect singly to one of these bulbs. Very bright. Which is very bright, but if I connect the 2 one after the other, it's not so bright. If I reduce the voltage as well, instead of using this 4-cell arrangement, I use just 2-cell arrangement, 2 batteries here, this one, and connect that across the 2, then you'll see that that's pretty dull when it switches on. So we've got 3 things to consider here. We've got the voltage, in other words, how hard are the batteries pressing. Then we've got the resistance of the bulbs, and then we've got the electric current that actually flows. And what happens if we double the resistance? We essentially halve the electric current. If we double the pressure, then we effectively double the electric current.
Ignore the red for a moment, but this formula up here in blue and green tells us everything to do with resistance, current and voltage. So this tells us what the current is based on the voltage and the resistance. So as you can see from the formula, if we double the voltage in volts, then that will double the current in amps. So current is normally designated by an I. Don't ask me, it's a historic thing. So if we double the resistance in ohms, then you'll see that the current will halve in amps. Let's just work through an example here. If we've got 3 volts across 100 ohms, then the current is going to be 0.03 amps, or 30 milliamps. That means 30 thousandths of an amp. So just as you can have millimeters, meaning a thousandth of a meter, so you can write milliamps, a thousandth of an amp. And that is essentially Ohm's law. And it's fairly fundamental. You don't need to learn it off by heart, because what you'll find is that as you do more and more electronics, you'll just remember it. And besides, I'll be reminding you along the way when we need it.
So here's one of the resistors from out of my little box, and I'm going to use that. I'm going to show you now what resistors actually do. Right, well, we've already seen our bulb and battery. So again, I've got the two cells here connected together. So this will give me 3 volts of electrical pressure or voltage. And if I connect that to the bulb, it lights up. But what happens if I put a resistor in the flow? It's in the path, the circuit, and when I connect them up, well, it lights up, but it's very, very dull. That resistor is resisting the flow of electric current. That's what resistors do, resist the flow of electric current. It's as simple as that. So here's one of the capacitors out of my little box, and now I'm going to show you what capacitors do. Capacitors store up electric charge. So what I'm going to do is I'm just going to connect this capacitor across the battery. Forget the bulb for the moment, put that somewhere else so it's out of the way. You just need to be careful when connecting up, because these capacitors are polarized. There's a negative there, which means that's where the black lead is going to need to go, and the red lead obviously therefore goes on the other lead. So I've connected the 2 leads and left it connected for a second or two, and now I'm going to take that capacitor and I'm going to connect it across the electric bulb, and let's see what we see, if we see anything at all. Here we go. Nothing at all. Nothing at all. Well, the capacitance of this capacitor is not very big, so I'm going to try now using a much bigger capacitance. And here's my bigger capacitor. So this capacitor is only 1000 microfarads, but this capacitor is 47,000 microfarads. So it's 47 times more capacitance. It can store 47 times more electricity in it than the first one. Again, we need to be careful because these capacitors are polarized. There's a negative and a positive lead. So make sure you connect the red lead, which is the positive from the battery, onto the plus sign here, and the negative onto the other one. So let's just connect that across the battery. I'll leave it for a few seconds and hopefully that's going to charge up nicely. There we go, hopefully it'll be charged by now. And now I'm going to take this bulb out of the stand. I'm just going to connect it across the top there, and we'll see whether we get a bit of a glow. Oh, there we saw. So there we go. It rapidly decreased, of course, as the capacitor discharged. Let's just charge up that capacitor again and see that again. So connect the 2 leads across, and we charge it up, and then put the bulb across. And this time, take notice of how bright that glow is. So you saw there. Let's use twice the voltage now. So there it is, my other cell. Let's use twice the voltage and charge this capacitor up to twice the voltage. And I bet you're thinking, what's going to happen with the bulb that's going to be different? So we're charging up the capacitor. Okay, it should be charged now, and put the bulb across it, and let's see what happens. And it was a lot brighter, wasn't it? So that's what happens when we got twice the voltage in this 47,000 microfarad capacitor. So that's what capacitors do. They store electric charge. So we've talked about electric circuits. We've talked about some basic components, the battery, the little electricity pump that pumps the electricity around the circuit, in this case through the bulb here. We've talked about bulbs a little bit. We've talked about resistors that can resist the flow, and I've got 3 different resistors just here for you to see. And we've talked about capacitors that can store electric charge. All of the components that we've been using so far can be bought from either Amazon or eBay. Also Rapid Electronics are a useful supplier of components.
I haven't talked about the components known as radio valves because they're obsolete. And in the next program, I'm going to introduce you to the family of components that made them obsolete, the semiconductors.